We're going to look at connecting a motor drive to a network, specifically a CLICK PLC to a GS2 VFD drive. First, let's overview what a CLICK has. It has 3 communication ports. You may be familiar with this one for programming. This one we might put a HMI in. They're actually very similar ports, identical, serial ports, point-to-point, not networked. The third port on many of the CLICK PLCs has a Modbus connector. This allows us to create a network. And that RS-485 is the network, and it supports 2 protocols or systems, the Modbus RTU standard or ASCII. Wiring for port 3 is just twisted pair and pretty straightforward. Flexibility options are this device can talk to devices that talk in the ASCII, such as scales, barcode readers, that type of thing, or a more efficient transmission way for a lot of things is Modbus RTU slave devices. So temperature controllers, printers, motor drives, all sorts of devices. The standard Modbus has been around for many decades and means it's included in most every component as a standard option for networking. 3 things we're going to have to tackle. One is the wiring. So when you refer to that, look at it, it's 3 wires, twisted pair. They have to be parallel in wiring. So when you look at that, this plus wire is going to go here as well as here. And the same would happen depending on how many other devices we might add. I think there's something like 247 devices that can be networked. So that's a pretty powerful choice there. The next wire, same sort of thing, has to go not only there, but as we see a node here, has to go here. And we'll ignore that little blurb there for right now. The main thing is to understand that's there, and you may see a 3rd wire, and often a terminating resistor may be included at the end of the network to get rid of any excess echoes or noise. So the signals are pretty simple. The network status lights are simply lights that light up, and there's a video you're going to watch that shows the lights activating, and those lights allow being able to see it, and if that pattern changes, you're going to see that means there's something changed in the network. Probably a device is not communicating, the port is bad, more likely the cable's not hooked up. The other thing about these lights is notice their rate, and they should stay the same. This will probably be done for you in this lab, but it's worthy to know that there's a couple things that have to be done. One, the PLC is the master, and that means there's certain things that have to be declared. What is the node address of the first thing on the network? Could be the PLC at 1. So when we think of a network, we're talking about things talking to each other. And we've got all the same wiring, or it might look cleaner this way. They've got all the same wiring. This is the network, which allows us to share information. But this might be node 1, node 2, node 3, so that when the master wants to talk to it, it says, hey, number 3, I'm giving you data. Or number 2, I'm taking data, I'm receiving something. The other settings all have to be the same. So in other words, we need to have, if you want to call it a language, if we're going to use English here, we need to use English everywhere. So that refers to the baud rate, the data settings, and the protocol. The programming then, after the port is set up, is simply the programmer selects the port that they want to use. They select what it is they're going to send. So starting master address or starting master address, what they're going to send. And where is that coming from on the slave? All of the other information, it can send two different things. It can send bits, which are on and off, or word data, which are things like numbers and text. It can also use a variety of addressing numbers, CLICK or Modbus addresses. Those are kind of generic addresses as they cross devices. The system has a bit that says, hey, is the port 3 ready? It also has an error flag that could be used, or another bit that says, you know, something happened. Somebody pulled the cable. The programmer could decide to stop sending, put a message on the display that there's an error. Or not, and then you just have to kind of trace it through. We have this going in our system here. It allows for reduced wiring, remote monitoring of signals. So this main system here is able to see the signals over here because there's a network. And again, there's a video you'll be watching on that. So that's the fundamentals of making this. You've got to remember to connect the wires in the right way, make sure the programs are loaded. Anything you talk to, it's got to be given a node address in that data. And you'll be walking through this in this series.